In this question, a scientist has 27.3 grams of hydrogen, H2, and 1,300 grams of selenium, Se8. Our goal is to figure out which is the limiting reactant and what will the enthalpy change of this reaction be given these amounts of reactants. Our first step is to balance our equation. I'm not going to show how to do that here. If you need more practice on that, head back to Unit 14. To balance this equation, we're going to use the coefficients 8, 1, and 8. Notice we've also been given the enthalpy change of reaction, which is 238 kilojoules for 1 mole of the reaction. Our first step is to figure out how many moles of each reactant we have present. So we're going to need to find the molar mass of H2 and Se8. Here's hydrogen. It has an atomic mass of 1.01, and here's selenium. It has an atomic mass of 78.97. So hydrogen has an atomic mass of 1.01. So for H2, that's going to be 2 times 1.01, which is 2.02 grams per mole. For selenium, the atomic mass was 78.97. So for Se8, the molar mass is going to be 78.97 multiplied by 8, which gets us 631.76 grams per mole. So our conversion factor for hydrogen is that we have 2.02 grams of hydrogen in 1 mole of hydrogen. And for selenium, Se8, our conversion factor is that we have 631.76 grams of selenium in 1 mole of selenium. So those are our 2 conversion factors we're going to use here. So first, let's convert our grams of hydrogen into moles of hydrogen. So we're told in the question we have 27.3 grams of H2. Let's set up our dimensional analysis table. We know that 2.02 grams of H2 is in 1 mole of H2. So if we multiply everything on the top, cancel our grams of H2 and divide top by bottom, we're left with 27.3 times 1 moles of H2 divided by 2.02, which gets us 13.5 moles of H2. We can fill that in over here. Awesome. Next step, let's find how many moles of selenium we have. So we'll put our given here first. 1,300 grams of Se8. Set up our dimensional analysis table. In 1 mole of Se8, there are 631.76 grams of Se8. We're going to multiply everything on the top, divide top by bottom. Grams of Se8 are going to cancel. We're going to be left with 1,300 multiplied by 1 mole of Se8 divided by 631.76. That's going to leave us with 2.06 moles of Se8. Awesome. Okay, so our next step is to figure out which of these is the limiting reactant. So I'm going to pick one and figure out how many moles of the other would I need to react completely. So I'm going to choose 13.5 moles of H2 and figure out how much Se8 would I need to react with that. So I'm going to start with my 13.5 moles of H2. Going to set up my dimensional analysis table. And I want to convert from moles of H2 into moles of Se8. So using my equation here, 8 moles of H2 combines fully with 1 mole of Se8. So that's going to be my conversion factor here. 8 moles of H2 goes with 1 moles of Se8. So I'm going to multiply the top together, divide the top by bottom. Moles of H2 are going to cancel. I'm left with 13.5 multiplied by 1 moles of Se8 divided by 8. That leaves me with 1.69 moles of Se8. So if 13.5 moles of H2 fully reacted with Se8, we would need 1.69 moles of Se8. However, we can see here that we have 2.06 moles of Se8. We have more moles of Se8 than we need. So that means that Se8 is in excess and that H2 is going to be our limiting reactant, hydrogen. Awesome. Okay, so our final step now is to find the enthalpy change. So we know we have 13.5 moles of hydrogen that's going to completely react with the excess of selenium. So all we need to do is convert our moles of hydrogen into the enthalpy change for the reaction. So let's set up our dimensional analysis table. First, we're going to need to convert from moles of H2 into moles of reaction. So looking at our reaction, we can see we have 8 moles of H2 in 1 mole of reaction. So that's going to be our conversion factor for this first part. 8 moles of H2 in 1 mole of reaction. Finally, we're going to need to convert from moles of reaction into kilojoules of energy. And we're given the enthalpy change of reaction here, which tells us that 238 kilojoules is the energy change for 1 mole of reaction. So that is going to be our conversion factor for this last step. 1 mole of reaction is 238 kilojoules of energy change. We're going to multiply everything on the top, multiply everything on the bottom, divide top by bottom. Moles of H2 are going to cancel, moles of reaction are going to cancel, and we're left with 13.5 times 1 times 238 kilojoules divided by 8 times 1. If we put that into our calculator, we're going to get an answer of 402 kilojoules. So we can fill that in over here. So again, this works exactly like any other limiting reactant problem. The only difference is that we're going to be using that enthalpy change of reaction as our conversion factor between moles of reaction and the enthalpy change.